Yeah, why are you doing that? Are you not a candidate?
Oh, I mean, they have a write-in portion.
Huh?
They have a write-in
Why are
portion.
you doing that now when other people... Why am I doing this on the
I
internet?
don't know. I want to
And whether you're ready or not. Here we go. That was an awkward start. All right. So, whether they want to zip it or not, I'm going to get going. Okay, and I don't think you really need me for this, but what does series mean? Sum. So, what people mess up is the difference between sequence and series. What is that up there? Arithmetic sequence. A sequence is a list of numbers. A series is a blank of that list. Sum. So, does everyone recall this? I actually pulled this from a PowerPoint that I used last year for our notes. Well, you weren't in my class. All right. So, if you remember when I did this, I talked about Freddie Goss. Freddie Goss is I don't know, he's a big mathematician. He did something, I don't know, proved something or calculus or something. I don't know, I don't remember. But I do remember this story that he was a little punk kid in school, like I don't know, 8, 7 years old or whatever. This is back 3, 4, 500 years ago. I don't know how old he is. Look it up, Google it. And his teacher gave him busy work. Him in the class said, "You know what, class, you're irritating me. Just go ahead and add the first 100 integers. Just do it." Of course, I'm adding to the story. I don't know if this is how it really worked out. So there it is. Dot. Freddie Goss got this done in, let's just say, under a minute, maybe under 15 seconds. Because all he did was a pattern. What's this plus this? 101, only one person knows. What's this plus this? 101, what's this plus this? How many of those are there? 50 101s. And he was good at multiplying. So he ended up getting the answer. Actually, it's very easy to do this. 50 times 100 plus 1. What's 50 times 100? 5,000. What's 50 times 1? 5,050. Handed a sheet to the paper or to the teacher, and teacher was mad because went too fast. So how come this is arithmetic? What's the common difference? 1. Now what's redundant? And here it is. Here's Freddie Goss. 1, 100. 100 divided by 2 is how many terms? 50, or how many how many terms with that sum being 101. So it only works for arithmetic. I think we remember this from last year. Those that are redonkulous have a non-arithmetic series, and they use this formula. And what kind of answer do they get? Starts with a W. Wrong. Okay. And then I guess the other thing, remember this? Everyone remember this PowerPoint now with that little boy in the corner there? It was moving and his pencil was moving and he's scratching his head like he has dandruff. So what you're supposed to recognize, okay, we talked about this yesterday because I showed those old school notes, that is a sigma notation. This means add from the 1st to the 24th, blah, blah, blah. But the next thing is this is an arithmetic sequence formula. This generates the terms. Then this says add those list of terms. So what your next job is to understand that this is arithmetic with a common difference of what? Well, if you cheated and look down here, it actually is 5. Because every term, as you plug in a number 1, 2, 3, 4, the difference from the term to the next term is 5. So what this actually says, and this is most of you did not get tricked on this, but when I teach regular cat, they mess this up all the time. If I'm going to ask you to add 24 terms, what am I probably saying? There's probably a what? For formula. I actually had on the regular Algebra 2 test back in the day 1 to 111. And I actually had a student write all 111 terms out and then add them. And they got that one question done and the rest of the test was blank. You understand what I'm saying? Okay, but they got that one right. All right. So this is what it's saying, but actually, for the love of dog, you'd use this formula, all right, and it would be quick. It's arithmetic because it's a difference of 5. So I guess what we're saying here is recognize an arithmetic sequence by its formula, and then use the arithmetic series formula. House of Cards. I won't say anything that I said second hour because it's online. Anyway. I don't know how to do that. I don't know. I just felt like it's time to tell a story. So mom felt guilty. Hey, how many cards are in the first row? 3. How many cards are in the second row? 6. How many cards are in the next row? 9. How many cards do you think would be in the next row? Sounds like a bunch of animals in here, doesn't it? YouTube. All right, now, so what is this? Arithmetic. Okay, so write the nth row rule. A sub n equals, actually you can think about this without even 3n. Of course, you could do the old 3 is the first term plus n minus 1 times 3 is the common difference, and you still end up getting 3n. That's the sequence formula. I did this thing last year. It's real easy. There's a word problem in your book. You'll be able to figure it out with finances. I don't have to cover any other with that. But then what does it say here? What is the total number of cards if the house of cards, if I could speak, has 14 rows? That is a sequence or series question. Series. What do we need, though? The 14th term. Which is what? 42? And then we have 7 sums that would equal the first term plus the last term, just like Freddie Goss. And then you can get your answer, right? Now this is a geometric sequence formula. This is a geometric series formula. No driving of this one, just write it down. You don't have to write all this. Just write the formula. And if you remember last year, I had you do this. Like, hey, class, could you add those numbers real quick for me? Of course, nobody did. Class, could you type the calculator buttons, help a fella out? And it took like 5 minutes. Then we got the answer. They said, hey, what is this? Bloop, 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 bloop. When you divide backwards or go forwards, if you can't figure it out, divide backwards. It's 2, common ratio. So it's geometric. So I said, hey, folks, let's try and see if this formula works and see if you match the sum that you got when you physically added those numbers. And it did. So what I just wanted to see and show you that it works when something's geometric. When it's not geometric, guess what this formula doesn't do? It doesn't work. How are you going to get an R anyway if it's not geometric? I don't know. People using formulas when they shouldn't. Ridiculous. Then, let me pause this. Then your job for this one is to recognize that this is what kind of situation right here? Geometric. What is the common ratio? 3. So your job as a student is to recognize that's geometric, so then I can add these 16 terms using a formula. Okay? And now, by the way, it doesn't always have to say I equals 1. It could say I equals 4. What if that said 4 to 16? How many terms are you adding from the 4th to the 16th? Would it be 12 or 13? 4, you had the 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. Isn't that 13 terms? Am I just going crazy, or did I just find 13 terms there? Anywho. Yeah. So I can go ahead and do this. Now, how many people don't have a fraction button on their calculator? Raise your hand. Okay. So you better be able to do that, right? And get the answer. So I guess part of the notes is you can type that on your calculator appropriately. Do you remember the girl and I think her ponytail was moving and her legs were kicking up and down in the... Yeah, this was the PowerPoint. Yeah. Okay. Then we analyze this. By the way, how many terms are we asking to add right there, if you can see? an infinite amount. Okay, so the first term is 2, the second term is 1, and then if you kept going forever, what theoretically would the last term of the sequence be if you could get there? What's 1 over infinity? 0. You could see these numbers getting so small, or the denominator getting so large. All right, so since essentially the last term is 0, there is a sum that is determined before we get there, in a way. And of course, if the r was greater than 1, pretend this was 2, then everything would double. So if the first term was 2, just let's say next term would be 4, next term would be 8, next term would be 16. What are those numbers doing? Going up forever, so therefore the sum would be what if you tried to add that infinite sum? Infinity would be too large, so that's a diverging sum. Okay? I talked to the calculus teacher, and this always baffled me. What would you think then under that terminology, I guess? Let's say n equals 1 to infinity. What do you think would happen with this one? 1 over n. I found this fascinating. According to her, she said something about this. But what would the last term be? It'd be the same thing. 1 over infinity, which is what? 0. She literally told me, no, this does not actually have a finite sum. Showed something on the board that I kind of got at the time, but so what I cut out of the book because of that conversation was something right in your pre-calculus book. The idea of convergence and divergence, and it's a very big part of your calculus course, and it is complicated. So at some point you'll figure out why this is a divergent, according to her, why this diverges. Very strange. To me, it baffles me, and I'd have to learn more about it. But so only a geometric sequence / series that has an R value that is between -1 and 1 will you have a finite sum. Now, I proved this last year. What if R is that half, right? What if I wanted to do S sub infinity? Well, the formula says I have to plug in infinity for the power of R. What's 1/2 to the infinite power? 0. What's 1 minus 0? 1 times a sub 1 is what? A sub 1. You're not memorizing two formulas. This is the same formula as this, except for the R disappears when it's the appropriate R. An R between -1 and 1 is the best way to say it. Okay, and then it ends up just being that formula. All right, so it's got to be under the right conditions. And it's redonkulous when it's not the right conditions when you use this formula inappropriately. I'll do that, and you'll get the silliest answer in the world. So Fadermact, we're going to do it right now in example 3. But here's the PowerPoint, and it all revealed itself slowly. Each little term, I don't think we need that. Appropriate R, the numbers are going to decrease. The first term is 5. Actually, if you were to take this and add those all together, you'd only get 15 halves. What is 15 halves? 7.5. So what's funny about this is the first term is 5. The second term is 5 halves, right? What's 5 halves? Wait, something's weird. I never was good at math. 5/3. That blew my mind because that was already 7.5. I was like, wait, what happened? All right, what's 5/3? Isn't that 1.666? So just adding these two together already, just the first two terms, you're at 6.6 repeating. Then when you add the rest of them, the sum only ends up being 7.5. Isn't that weird? That's how insignificant the terms get and how fast they are insignificant. Then we get the sillies. Oh, I have to use an infinite amount of terms and add an infinite amount of terms? Mr. Samuel said it was this formula. First term divided by 1 minus r. I get it all the time. What's 1 minus 2? I got it. It's -1. No, don't anyone do anything. All right, then what's 1/2 divided by -1? So seriously, the sum of all those terms forever equal -1/2. When the first term is 1/2, the second term is 2 times 1/2, which is 1. The third term is 2. So those add up to -1/2 as I keep going forever and ever and ever. Huh? Yes. Already on page 6. All right, so then sigma insanity. Same thing with this. Example 6 cannot be done infinitely. And then I just threw in a random, hey, that's not infinite. Don't be a robot. We got to use the one where, this is what we got to do. And then I typed it on. Look at how I typed it. How crazy is that, huh? You know what's funny about this? Is this appropriate to add an infinite sum on this one? Take a wild guess what the infinite sum would be. 0.75. Is that wild? So just adding the first 11 terms, you're already almost at 0.75 already. If you added the rest of the 12 to infinite terms, it would just make it 0.75. Okay? I don't know. I thought that was interesting. Apparently I'm alone on that. Pendulums. And everyone in physics is like, oh, I hate pendulums. We always talk about pendulums in physics. That's what second hour did. That's how they sound too. The whole class all together. All at once. So pendulum swings 18 inches. Yeah. Then it swings only 80% of that. And then 80% of that. And then 80% of that. And then 80%. Theoretically, what's this pendulum never going to do? Stop. Isn't that weird? Just like that thing, if I walk halfway to that wall and then walk another half to that wall and then another half, what will I never do? I will never reach the wall. Wild. Okay, so why is this a thing? I want to find out, what does it swing forever? What's its distance? First swing is 18 inches. What's the next swing? 18 what? Times, well, just tell me the thing. All right, 0.8. And then what's the next one? Times 0.8 times another 0.8, right? Because 80% of the previous swing. And so on and so on and so forth. So what kind of scenario is this? Geometric, and it's infinite. So what's the first term? 18. What's R? 0.8. Ooh, he's going 4/5 on me. What's 18 divided by 0.2? I got no one do a thing. No one do anything. I'm here for you. By the way, read the directions, which I did not do second hour. So what do I have to use? Summation. What letter do I need? Sigma. What are we going to call this term? So n equals 1. What's the problem? I don't know what term this is. Right? What kind of scenario is this? Arithmetic. What's the common difference? What's a sub 1? So watch this. 29 equals 2 plus, what are we trying to find? N. And what's D? 3. Now this took a half hour, second hour. What's N equal to? N equals 10. So now we can we're adding up to 10 terms. Oh, and then by the way, we should have actually done this. A sub n equals. All right, and then when you distribute, that's what goes here. So understand the structure of a sigma. It's sum the sequence. So I actually need the sequence formula here as well. So that is -3 minus 1. Is that right? Someone confirm that? Thanks. What's this next one? What do the dots mean? Ugh. And then, anyone? Remember getting marked wrong on the game? -3 needs to be in parentheses. N minus 1. All right? Oh, look, the answer. This one actually says find the sum. I'll just go ahead and do the rigmarole. By the way, what is it? So 27 equals a sub 1 plus n minus 1 times d. Offline, let's get what n is. Is it? So n equals 29. All right, and then this one I actually have to find. So why did I need 29? It's arithmetic. So I needed this number. Because I had the first and the last term, but I need to know how many terms I'm adding that has this sum. And you can get the answers. 2001, good. Actually, it wasn't a good year, was it? Never mind. Now look at this. Is this 5, comma, 15, comma, 45, comma, dot, 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 comma, 98, comma, 415? No. Second hour came up with some good, like, isn't there a little space there? You see that little space? Comma space 45. Is there a little space after that comma? So 98,415 is a term. Don't get corn fused on that. Corn. Okay. Now this is hilarious. I will say the second hour. After we got the formula, we got the answer. I go, all right, what's the answer? And he or she, let's keep it. She goes, it's 28,532. That's true. How could it possibly be 20? We all laughed and like, sorry. Sorry. All right. Sorry. I like telling stories. Yeah. So, what's R? 3. Okay, so what we need to find out is what term is this? Oh, this is awesome. Wait till you see this. So 98,415 equals A sub 1 times R. Wait, R says 5. I wasn't done yet. Everyone's so... Times 3 to the... Oh, no. I need to know what term this is, right? So n minus 1. Is that right? Oh, what do I do first? Divide by 5. Go ahead and do that, please. Oh, this will take about 20 minutes. What? 680 what? 3 equals 3 raised to the n minus 1. Does anyone know what we're going to have to do to solve for this? Logs. Log base who? What's LO6? 3. 19. 83. Right. I forgot about that. And then n minus 1 equals. So n equals 10 when we get that. So this is apparently 3 to the 9th. 19,683. Who knew? All right, so why do we have to do all that? Hold on a second. Yeehaw. All right. Geometric series. So sum of these 10 terms equals a sub 1. 1 minus, what's R? 3 raised to the 10th all over 1 minus 3. Careful how you type it on your calculator. Do. All right. I was doing that to myself. Hey, what term is this? Obviously, it's multiplied by negative 1/6. What term is this? It's actually the 10th. And then you go ahead and go from there. And then actually find it. And then, wait, no, do you have to? No, because you just need a sub 1 and R. So you know how to do that. Be careful how you type this, though. It's a sub 1 times 1 minus R raised to the, there's 10 terms, right? Over 1 minus R. Now, do you take these two and cancel them, yes or no? No. Okay, so you got to make sure. Oh, by the way, what's 1/6 to the 10th negative? What kind of number does that become? Positive, but then it's 1 minus that positive. So there's some things you better watch out when you type this on your calculator. Here we go. By the way, what's 0.3 repeating? A number. 1/3. What's 0.71 repeating? Anyone know that? Actually, we're going to prove it on this one. I'm still going to do it the long way because it doesn't really help you on this one. The next example I created myself. It's actually 71 over 99. Check it out. If you do 71 over 99 in your calculator, you get 71717171 forever. By the way, what's 0.71 with no bar over it? 71 over 100. So we actually know what this answer is. It's 5 and 93 over 99, and then we could turn it into a mixed number. But I'm going to prove it through series ideas. This is 5 plus 0.93 plus 0.0093 plus 0.000093 plus, can I stop? Okay, so what does this part represent? An infinite series. What kind of sequence is this? I said sequence, now how are these terms generated? Geometric, what's a sub 1? Am I taping? 0.93. What is R? Well, what do I have to multiply this by to turn it into this? 0.0 1. That's what R is to generate these terms. So this could be, to prove this 93 over 99, this could be rewritten as 5. Understand 5 is not part of this infinite sum. Keep it separated. Keep it separated. 0.93 a sub 1 over 1 minus 0.01. 1 minus R. So it's 5 plus whatever this is. By the way, what is 1 minus 0.01? 0.99. And you remember in your fraction days, if I have two decimals over two decimals, I can move them both, or multiply both top and bottom by 100. Lo and behold, I get 93 over 99. So 5 and 93 99ths. Doesn't help you on this one, though. But you got to do the same idea. 0.74 plus, I made a mistake second hour, it's 0.00, so I can add that and put that there. 39 plus 0.00000000, and so on and so on and so forth. So yet again, what is this? An infinite geometric, big yawn, series sequence series. It's actually series. Okay, so all right, let's do this. So what's 0.74? 74 over 100 plus the infinite geometric series. A sub 1 is 0.0039. And then R is what? Still 0.01. And then here's the idea. How many spaces it repeats? You know, if it was 397, 397, 397, it'd be 0.001. 3 spaces, for this. All right, so it's 0.0039 over 1 minus 0.01 again. Now, I'm going to do simple math here. This again is 0.99, right? And then I'm actually going to move this decimal 4 places. That means I'm going to move this decimal 4 places. Huh? So it's 74 over 100 plus 39 over 9900. So what do I just have to multiply this one by to get a common denominator? And actually, I should do reducing, but I'm just going to make this simple. Go ahead and multiply that, add it to 39, and we'll put it over 9,900. And now we use our little fraction button on our calculator. Hey, turn around and divide these. Take 491 divided by 660, and be amazed what you get. 0.74 or 3939393939. It works. People are putting their stuff away. They think it's done. I just want to make sure you understand what partial sums are. I'm doing 24. You have to do 23 or 25. I think it's 23. Who cares? Find the first 6 partial sums. Here's what a partial sum is. What's the sum of just the first term? -2. What's the sum of the first 2 terms? So this is the second partial sums. What's the sum of the first 3 terms? What's the sum of the first 4 terms? Sum of the first 5 terms? First 6 terms? There's a pattern, but is this diverging or converging to a sum? This is called what? This is what? Oscillating back and forth between 0 and -2. So this diverges because what are you going to say if you're going to find the infinite sum? Well, I don't know where it ends. It's either going to be 0 or -2. It doesn't really converge to one number. But how about this one? This one's strange, and it baffled me. And then someone said something second hour. I didn't really listen, and then they said it again. I listened. It made sense. It's really kind of easy. But why does this converge? What's the sum of the first terms? 1. No. What's the sum of the first 2 terms? 0.3. What's the sum of the first 3 terms? 0.23. What's the sum of the first 4 terms? 0.223. 5 terms? 0.2223. And then 6 terms, what could you think? Is this converging? Well, yeah, it says so. But what do you think it's converging to? 0.2 repeating, which is actually what? 2/9. Now, what's weird about this is this geometric? Yes or no? This is what baffled me. What's this divided by this? Negative point. It's easy. It's negative 0.7, right? Divided by 1. But then what's this divided by this? Is it the same? No, but what if I get rid of this? What if I do this divided by this divided by this divided by this? What's R for those? You guys don't know what 0.07 divided by zero point 0.7 is? How we'd get 2/9. It's 1 plus, just like that repeating fraction thing. You know, this repeating fraction up here? I had to separate this part as not part of the infinite sum. So it's geometric after the first term, so I could still figure out the sum, and it does converge to something. What's the first term when we started off after this? What's the first term? Negative 0.7 over, what's R? 1 minus zero point 0.1. Okay, and then hopefully we end up getting 2/9 when we do that, otherwise I made a mistake.